Hi everyone. All right, so here we are, day 2 for chapter 5, and we will be talking about the average atomic mass and more about the periodic table. Okay, so some things that you should get out before we start. You need your periodic table out and a calculator, okay? All right, so let's continue with average atomic mass. So average atomic mass is different than the mass number that we talked about on day 1. So if you remember mass number from the first lecture, mass number is a whole number that you get just by adding protons and neutrons, okay? When we talk about atomic mass or average atomic mass, it's different. It's a weighted average, okay? It's a weighted average of all the existing isotopes. Weighted average. So it's not a whole number, and that's why on the periodic table you see that the masses actually have fractions, like the decimal places and stuff. So let's just enlarge this periodic table a little bit so you can see that. So you'll notice here, laser pointer, okay, so you'll notice like right here, like 9.01, that is what we refer to as a fraction. So they get those fractions or those decimal places by using the weighted average or calculating the weighted average, okay? So let's take a look at this example here, and this is for copper, okay? So these are 3 isotopes of copper, copper 12, copper 13, and copper 14. Then you can see it tells you the percentages of each of those isotopes in which they occur in nature. That is what we call the abundance. How abundant are they in nature? So most of the carbon that you find in nature is carbon 12. That means carbon with a mass of 12. And then all of these carbon 13, carbon 14 are in much smaller percentages in terms of being found in nature. So what we're going to do is we're going to take a weighted average of all of these, and then that's how they got 12.01, okay, AMU. AMU stands for atomic mass unit, okay, the atomic mass unit, which is very similar to the grams of the substance. All right, so now I'm going to teach you how to calculate a weighted average. All right, so here we go. This is an example, so go ahead and make sure you read it to yourself first. So we're talking about copper. It has 2 naturally occurring isotopes, copper 63 and copper 65. Okay, then take a look at the information that's provided for each isotope. 69.17% of copper 63, and that is the mass for that isotope. The next isotope, 30.83%, and then it has that mass value. Now it wants us to calculate the average atomic mass. So we have to calculate what is the weighted average. So we're going to take in consideration the percentage, and you're going to multiply it by its corresponding mass. But don't forget, over here, take a look at your percentage. You need to turn your percentage back into an ordinary number, okay? So in other words, you need to move your decimal here 2 places to the left, all right? So move the decimal 2 places to the left, and then you're going to multiply it with its corresponding mass. You do that for each isotope, and then you're going to add them up together, okay? So multiply the percentage with the mass for each isotope, and then add up all of the isotopes together. Find some empty space on your notes and try to do the math all by yourself first. So if you did it correctly, this is what the work should look like, and then this should be your answer, okay? So the average atomic mass for copper is 63.55 AMU. Notice I put units here, okay? The atomic mass unit. So see how the percentage is right there with the decimal moved over 2 places to the left, okay? Multiplied by the corresponding mass for each one, and then you add up each of the isotopes. So you definitely need to know how to do a problem like this on your test. So they are most likely going to be free response questions, okay? Now we're going to talk about the periodic table and the different categories that the periodic table is made up of. So make sure you get out your periodic table. You can read all of this stuff here. It's in your notes. I'm actually going to go to the next slide so we can take a look at the different categories. All right, so first let's talk about the metals. All right, the metals. So the metals are here in the gray section. So everything that's gray here are metals. So you can see that the periodic table is mostly made up of metals, okay? And then your metals, some characteristics of your metals, they're good conductors of heat. They can conduct electricity. So you know that they're good conductors of heat because we use them to make our pots and pans. And a lot of metals are used in wiring, like copper wiring or even aluminum wiring. So we know they conduct electricity. All right, now we're going to talk about your nonmetals. Non-metals, those are the ones that are colored yellow. So that's hydrogen over here. All right, that is a non-metal. So your non-metals are the opposite. They are not good conductors of heat and they do not conduct electricity. Okay, now we have your metalloids. The metalloids are usually along the stair-stepping line here. Okay, and those are the ones that are blue. This box right here, which represents boron, it depends what periodic table you're looking at. Some periodic tables include boron as a metalloid and some don't, okay? It's really not that big of a deal. Besides metalloids, we also call them semi-metals, okay? Semi-metals. Make sure you know both terms because sometimes the test might say metalloids or it might say semi-metals. So the stair-stepping line, once again here, separates the metals from the non-metals. And so the metalloids or the semi-metals are in between. Okay, they have characteristics of both metals and non-metals. So they do conduct a little bit of electricity, all right, but not a whole lot, but some. Like silicone is a very popular metalloid. That's why we use silicone in computer chips and stuff because they conduct just the right amount of electricity. So what I like to say metals are on the left side of the periodic table. Your non-metals are on the right side of the periodic table, okay? So once again, when I say metals are on the left, I mean the left of the stairs. When the non-metals are to the right, I mean the right of the stairs. One exception, obviously, hydrogen over here. Although it's on the left side of the periodic table, it really belongs over there. And that's just something that you have to remember. The reason why they put hydrogen way over here on the left is because they wanted the periodic table to look symmetrical. Some groups on the periodic table have a special name, and you need to know what these special names are. All right, so let's start with group 1. Group 1, they are called the alkali metals. Okay, alkali metals. And the alkali metals are highly reactive in water. Okay, they will explode in water, and they are very dangerous. They're highly, highly reactive. Now, obviously, hydrogen's kind of in a group all by itself. It's not a metal, so that's just something you have to remember. Okay, group 2. So group 2 is right here. Sorry, right there. That's group 2. So group 2, they are called the alkaline earth metals. Alkaline earth metals. Okay, so once again, group 1, alkali metals. Group 2, alkaline earth metals. And then we have the middle section of the periodic table here. Okay, those are the transition metals. Transition metals. And then the group here that's in gray, these don't have special names, okay? Some of the groups do not have a special name. If they don't have a special name, we just refer to them by their number, like group 4 or group 5 or group 6, okay? Now group 7, which is over here. Okay, it's group 7. These are the halogens. Halogens, okay? Halogens. And then the very last group, group 8, these are your noble gases. Okay, noble gases. So your noble gases are considered to be inert. So I'll spell that out, inert. All right, those are your noble gases. They are inert, which means they have very low reactivity. So they don't react much at all. So let's think about that. Well, if you remember way back in medieval times, had the peasants and the nobles. So let's think about that. Did the nobles interact with the peasants very much? No, they didn't at all. So same idea with these noble gases. They're already stable. They're not going to interact with anybody else. They are happy being all by themselves, okay? So that's why we call them inert. Very low reactivity. You're not going to see the noble gases in chemical reactions very often. Now let's take a look at the 2 rows at the bottom of the periodic table. So these right here. So those 2 rows at the bottom, they are called the rare earth metals. Rare earth metals. The reason why they are called the rare earth metals is because most of them are actually man-made. Okay, they're actually found in laboratories. Not all of them, but some of them. And so not a whole lot of them are actually found in nature. They're actually produced in laboratories. Besides rare earth metals, we also might call them the lanthanide series or the actinide series. That's just because of the element that starts those rows technically. Look at the numbers. 57 and then down here 58. So these 2 rows are really inserted there. The reason why they're thrown down at the bottom of the periodic table is to once again make the periodic table look more symmetrical.